Today we will be going to study about a new chapter, that is optics, which is one of the most important chapters that we are having in our second PU syllabus. And in this optics we will be studying about the light and the phenomenon of light, the different phenomena that are exhibited by the light we will be going to learn. So what is optics means? Optics is nothing but the study of light and its phenomenon. The study of light and its phenomenon is nothing but the optics. And this optics can be studied in two different ways. Optics can be classified into two types as number one is ray optics and number two is physical optics. The first one is ray optics and the second one is wave optics. So we are broadly classifying optics into two types as ray optics and wave optics. Coming to this ray optics, in this kind of optics we will be studying the phenomenon of light by treating light is traveling in the form of straight lines. That means treating light as a ray. So here this ray optics is also being called as geometrical optics. Geometrical optics. Whereas the wave optics is also being called as physical optics. Physical optics. So here we are classifying optics into two types as ray optics and wave optics. In ray optics we are treating the light as a straight line, whereas in the wave optics we are treating the light as in the form of a wave. Here we are treating light in the form of wave and here we are treating light is traveling in the form of straight lines. The other name for ray optics is geometrical optics, while the other name for wave optics is physical optics. Why this geometrical optics is named means, in dealing with the ray optics we have to consider some basic geometry, hence the name geometrical optics. The properties of triangles or the properties of some basic properties of the geometry will be considered, hence the name geometrical optics or the ray optics. Whereas in this case wave optics we are treating the light in the form of what? Wave. And now when to consider ray optics and when to consider wave optics we will discuss later on. So when we have to treat light as a ray and when we have to treat light as a wave, that is a important thing that we have to study in this chapter. And first we are concentrating only on the ray optics, not on the wave optics. In this ray optics we will be studying about the phenomenon of reflection and the phenomenon of refraction. So what we are studying in ray optics means the phenomenon of reflection and the phenomenon of refraction using the ray optics. These things we will study, and later we also study about the different optical phenomenon that we will be noticing, like the scattering phenomenon we will be studying, the formation of rainbow and other things we are going to learn in this ray optics. While we are studying about the reflection phenomenon, we will study about reflection at plane surfaces and reflection at curved surfaces. Reflection at plane surface and reflection at curved surface or spherical surface. Spherical surface. Similarly, we will study about the refraction at plane surface and refraction at curved surface. Plane surface and refraction at curved surface also we will study, or the spherical surface. Either you can call it as curved surface or the spherical surface. So in ray optics what we are going to study? In ray optics we are going to study about the reflection phenomenon, and that too reflection at plane surface we will study, as well as reflection at spherical surface we will be going to study. Later we will study about the refraction phenomenon. In this refraction also we will study about the refraction at plane surface and refraction at spherical surface. And here we will also study about some other concepts like lateral shift, normal shift, critical angle, total internal reflection, like that some other phenomenon we are going to study. And along with these things we will also study about the human eye as well as the scattering of light. scattering of light and the formation of rainbow. All these things we are going to study in this ray optics. And in the wave optics part, we are going to study about what? We are going to study about the reflection as well as refraction using the wave nature. Here we are studying about the reflection and refraction based on the ray nature of light, whereas in this case we are going to study about the reflection and refraction by the wave phenomenon. Along with that reflection and refraction using the wave phenomenon, we are also going to study about the reflection and refraction based on wave phenomenon in the case of wave optics. Along with those things, we are going to study about the interference phenomenon, interference, the diffraction phenomenon or the diffraction phenomenon, diffraction or diffraction, diffraction or the diffraction, how you want to spell, you can spell as you like. Along with that interference, diffraction, we are also going to study about the polarization. So, regarding optics, these are the important phenomena that we are going to study. What are the important phenomena that we are going to study means reflection and the definition for reflection, and in detail about reflection, definition for refraction and in detail about refraction phenomenon, interference which is an optical phenomenon, diffraction an optical phenomenon, and polarization an optical phenomenon. In first year part we have studied that all waves will reflect, all waves will refract, all waves will interfere, all waves will diffract, but only the transverse waves will be polarized. So that means all waves will reflect means what? All waves in the sense. That means what I want to say is the reflection, refraction, interference and diffraction phenomenon does not depend upon the nature of the wave. That means whether the wave is a transverse wave or a longitudinal wave, whatever might be the type of the wave, we are not bothering here. All kinds of waves will be going to reflect, all waves will be going to be refracted, all waves will interfere and all waves will diffract. But regarding the polarization, it is one of the most important phenomenon which is going to depend upon the nature of the wave. That means all waves cannot be polarized, only transverse waves can be polarized. Why transverse wave can be polarized we are going to study in the polarization topic. Until then, just remember that these are the different optical phenomena that we are having, and in the beginning we are going to study about the reflection, refraction, interference and diffraction, and lastly we are going to study about the polarization. All waves will reflect means sound waves is a wave, whereas light wave is also a wave. Light is a non-mechanical wave, whereas sound is a mechanical wave. Though it is one is mechanical, other is non-mechanical. Light wave is non-mechanical, sound wave is mechanical. Both of them can be reflected, refracted, interfere and diffract. But sound waves in gaseous medium cannot be polarized. Why? Because sound waves in gaseous medium are longitudinal type of waves, whereas light waves can be polarized. Why? Because all electromagnetic waves, that means even the light which also comes under the electromagnetic spectrum part, is going to be polarized. As light is transverse in nature, it can be polarized. Is it clear? So, and along with these things, we are going to study some other additional parameters in the optical phenomenon in the modern type of physics. That is, in the modern physics, we are going to study about the photoelectric effect. Photoelectric effect. Photoelectric effect we are going to study. Along with that, we will be studying about the phenomenon called photoelectric effect. Already in chemistry first year part, you have studied about the photoelectric phenomenon. And this photoelectric effect is a optical phenomenon that is exhibited by the particle nature of the light. It cannot be explained based on the wave nature of light. So that means here these phenomena can be explained based on the wave nature, whereas this phenomenon can be explained based on the particle nature of light. So here, why these phenomena are able to be are explained based on the wave phenomenon, and why photoelectric effect is explained based on particle phenomenon is a question mark. So, from these things what we are having what is the question that we are having means, is light a particle or a wave? This is the first question. In order to understand whether the light is a particle or a wave, we have to study about the theories of light. Actually, these theories of light will be there after the completion of ray optics, and at the beginning of the wave optics we are having the theories of light. But now I am going to explain the theories of light first, and then I am going to explain ray optics and wave optics. Okay. So, why I am going to explain the theories of light in the beginning means, we should know whether light is a wave or a particle. So, why to study about the light first is the question. So, why to study about light means, is there any importance while we are going to study about the light? Means, yes, most of the information that we are having today is because of the light. We are seeing the surroundings because of what? Light. If light is not there in the classroom, can I see anything in the classroom? Means, no, I can't see anything. When light falls on you people, I am able to see you, because when light falls on you and get reflected and forms the image on my retina part, then only I am able to see you. Whatever may be the object I am seeing, that is possible only because the light is getting reflected from that object and forming the image on my retina. That is why I am able to see that object. So, we are early morning session, all of you are going to see your beautiful faces in the mirror. Why we are able to see our beautiful faces? Because of which phenomenon we are able to see our beautiful faces in the mirror means, that is because of reflection phenomenon. Sometimes when you are playing in the water, we will be seeing our legs appear to be shortened. When we are standing inside the water and you look at your legs appear to be shortened. That is because of refraction phenomenon. Or you will be noticing the twinkling of the stars during night time. We are observing the twinkling of stars in the sky. Why the stars are getting twinkled? That is because of the atmospheric refraction. The twinkling of stars is because of what? Atmospheric refraction. So, many phenomenon that we are noticing is because of, or we are getting the information, we are gathering the information only because of the light. Though it is our eye is the most powerful organ which can be giving information for us by the sense of vision. Our ears are having the sense of hearing, whereas the eyes are having the sense of vision. The sense of vision is possible only because of the light. So, whatever information we are having today is because of, or we are understanding is because of the light. So, it is very important to study about the light, and we are having so many practical applications based on the light. So, we will be seeing the rainbow in the sky. That is because of what? One of the optical phenomenon called because of the optical phenomenons like refraction, dispersion, as well as the total internal reflection. So, nowadays we are having a powerful communication system. Optical fiber cables will be used in some kind of powerful communication systems. These optical fibers are working on a principle called total internal reflection, which is also an optical phenomenon. Or when you are seeing the diamond is getting sparkled. The sparkling of or the glittering of diamond is because of a particular phenomenon in optics called as total internal reflection. So, or else when we are when you are walking on the rainy during a rainy season, when you are walking on a road, on the water surface, whenever some diesel is or petrol is leaked onto that water surface on the tar road, you will be seeing the colored pattern. That is because of one of the optical phenomenon called interference. Or when you look at the spider web, you will be having some spectrum will be seen. Or when you pass light through a prism, we will be getting the spectrum, or the Webber colors can be noticed. That is because of the dispersion phenomenon. So, we are observing so many kinds of phenomenon around us because of the optics part. And it is very important to study about the optics, because while we are studying about each and everything, we will be understanding their importance and their applications. So, reflection is having its own application, refraction is having its own application, interference, diffraction, polarization, photoelectric effect. Even we know about the photoelectric phenomenon. When a light of suitable radiation is incident on the metal surface, it is going to eject the electrons called as photoelectrons. Because of that, we are having the photocurrent. that is called as photoelectric effect. This is also an optical phenomenon. These are the optical phenomenon, interference, diffraction, polarization of the optical phenomenon, which can be explained based on the wave nature of light. These can be explained only based on wave nature, only based on wave nature of light. Whereas these two, reflection, refraction, can be explained based on both particle nature as well as wave nature. Can be explained based on both particle and wave nature. Whereas this photoelectric effect, in higher studies we will study along with this photoelectric effect, we will be having the Compton effect. These are the phenomenon that can be studied only based on particle nature. Only based on particle nature. So this can be studied only based on the particle, and it can be studied, reflection, refraction can be studied based on both particle nature as well as wave nature. But interference, diffraction, polarization can be explained only based on the wave nature. They cannot be explained based on the particle nature. Only based on wave nature we are going to explain means we are unable to explain these phenomena using the particle nature of light. Whereas the photoelectric effect and Compton effect can be explained only based on the particle nature. These things cannot be explained based on the wave nature. So by studying about these things, what we are having means the basic question that we had is light a wave or a particle, is the first question we are having. So immediately we are able to say right now light is having the dual nature, but it has taken some centuries together to understand what is light. If I ask a question, what is light? Nowadays we are in a situation to say we are able to try what is meant by light. But if I ask a question, what is light? Though everyone knows what is light, but nobody can say what it is. Even a common man, if you ask a question, or if a layman is asked a question, what is light? He knows what is light, but he is unable to say what it is. Even we also, if a question is raised like this, what is light means, yes, all of us are knowing what is light, but we are unable to say what it is, yes or no. This is the phrase given by the famous scientist B.B. Lord. According to him, everybody knows what is light, but nobody can say what it is. Everybody knows what is light. But nobody can say what it is. Is it true or false? Yes or no? So we are knowing what is meant by light means we are knowing because of light we are able to see. Yes or no? We are in a position to say, but we are experiencing, but we are unable to say what exactly light is. In order to understand light, so many theories were proposed. Out of the many theories that we are having regarding the light, the four important theories that have given importance are, number one is Newton's corpuscular theory, number two is Christiaan Huygens wave theory, number three is the Maxwell's electromagnetic theory, and the last one is Max Planck quantum theory. So we are having four important theories that we have to study in order to understand whether light is a wave or a particle. So what are those four important theories that we are having regarding the light are, number one is Newton's corpuscular theory. And number two is Huygens wave theory. And the next one is Maxwell's electromagnetic theory. EM theory. And the last one is Max Planck quantum theory. These are the four important theories that we are having. and we will study in detail about each and every theory. What is Newton's corpuscular theory? What are the hypotheses of Huygens wave theory, Maxwell's electromagnetic theory hypothesis, and Max Planck quantum theory hypothesis we will study. So, actually regarding these theories of light, we have to study after the ray optics and before the wave optics in our textbook. But instead of studying in the middle, let us understand what are these theories first, then we will be studying about the ray optics and wave optics. Is it clear? So, now we are going to study about the theories of light. Regarding the theories of light, we are having so many theories, but the most popular theories are the Newton's corpuscular theory, Huygens wave theory, Maxwell's electromagnetic theory, and Max Planck quantum theory. And by studying about these four theories, we are going to have a conclusion regarding the nature of light. That means whether light is a particle or light is a wave. So, we will have a conclusion by knowing about all these four theories of light. So, in the beginning of the story, we will be studying that light is a particle. By the interval, we will be going to know that it is a wave, and at the end of the story, we will be going to study that light is having the dual character in the sense it is having both particle nature and wave nature. When does light will exhibit the particle nature and when does the light will exhibit the wave nature will be discussed in the course of time. Now, coming to this first theory of light, that is Newton's corpuscular theory. So, first we will understand the hypothesis of Newton's corpuscular theory. Actually, the corpuscular theory was put forward by the scientist named as Descartes. Descartes is the name of the scientist. Descartes is a person who has introduced the corpuscular theory. So, the concept of corpuscles is introduced by whom? Descartes. But later the theory was developed by Newton, and because of the superiority of Newton in those days, the name Newton's corpuscular theory came into existence. So, who has introduced the corpuscles? Means Descartes is the answer, not Newton. Though we are reading it as Newton's corpuscular theory, it was put forward, the corpuscles concept was put forward by Descartes. Later the theory was developed by whom? Newton. Hence the name Newton's corpuscular theory. It is just like the case. The concept of inertia in first year we have studied. It was introduced by whom? Galileo. But the credit has gone for whom? Newton. Yes or no? In Newton's first law is nothing but what? It is nothing but the property of, it is explaining the property of inertia which was proposed by Galileo only. So, in the similar way here also Newton's corpuscular theory is nothing but the enhancement of the Descartes corpuscular theory. So, now what is this Newton's corpuscular theory is going to say? So, who proposed the corpuscular theory means it was proposed by Descartes and it was developed by Newton, hence the name Newton's corpuscular theory. And what this theory is going to say? According to Newton's corpuscular theory, light consists of tiny particles called corpuscles. First theory I am explaining here. First one is Newton's corpuscular theory. Who developed this theory? This theory was developed by Newton, and corpuscles was introduced by Descartes. And what is this Newton's corpuscular theory says? According to Newton, light consists of tiny particles called corpuscles. First point, light consists of tiny particles called corpuscles. So, that means according to this theory, light is exhibiting which nature? It is consisting of tiny particles I am saying. That means corpuscle is treated as a particle. Hence, according to Newton's corpuscular theory, light is to be treated as a particle. And this light is travelling with a great speed equal to the speed of light, that is 3 into 10 power 8 meter per second. And according to this theory, these particles are moving in straight lines. So, the light is exhibiting the rectilinear propagation of light, right? Rectilinear propagation in the sense straight line propagation. So, what is meant by rectilinear propagation? Straight line propagation is called rectilinear propagation. Rectilinear means straight line, rectilinear propagation. So, according to Newton's corpuscular theory, light is having rectilinear propagation. Light is having rectilinear propagation. That means straight line propagation. Straight line propagation. And light is traveling with a speed equal to the 3 into 10 power 8 meter per second. And that means light is traveling with great speeds equal to, or the corpuscles are traveling with great speeds equal to 3 into 10 power 8 meter per second. Light is traveling with great speeds, equal to 3 into 10 power 8 meter per second. And next is, according to this Newton's corpuscular theory, light is traveling faster in which medium? Regarding the medium means which medium we need to consider here means we have to consider about the optical medium. What is an optical medium then? Optical medium is a medium through which light can propagate. Any medium through which light can propagate is said to be an optical medium. For example, light can propagate through water, so water is an optical medium. Light can propagate through glass, so glass is an optical medium. So, through the medium through which light can propagate is said to be what? The optical medium. And the medium through which light cannot propagate is said to be an opaque medium. Once again, we will discuss them later. But now, what is light is propagating with a speed equal to how much? 3 into 10 power 8 meter per second. And next, Newton proposed that light is traveling faster in the optically denser medium than in the rarer medium. So, according to Newton, light travels faster in which medium? Denser medium. Denser medium means here medium in the sense optical medium. Every time I am not repeating optical medium, simply I am using the word medium. So, wherever I use the word medium, it refers to the optical medium. So, now light travels faster in denser medium than in rarer medium, according to whom? According to Newton. According to Newton, light travels faster in denser medium than rarer medium. This is an important one. So, according to Newton, light is traveling faster in denser medium than in rarer medium. But now we know, at present we know that light is traveling faster in which medium? Rarer medium than in denser medium, which is against to this Newton's corpuscular theory. Newton has assumed that light is traveling faster in denser medium than in rarer medium. What made him to think like that means, at that time we are familiar with the sound waves, and sound waves are traveling faster in solids than in liquids, and which are traveling faster in liquids than compared with the gaseous medium. We know that speed of sound in air is 330 meter per second. Speed of sound in water medium is 1435 meter per second. And in the case of the steel, it is traveling nearly equal to 5000 meter per second. So, sound is traveling faster in which medium? Denser mediums than in the rarer mediums. So, in that context, he has thought that even light is also traveling faster in the denser medium than in rarer medium. And even he has given some explanation for that why light travels faster in denser medium. I will tell you later. So, but here, these, if you consider these things, what are the hypothesis of Newton means? Light is consisting of tiny particles called what? Corpuscles. And light is having the rectilinear propagation, that means straight line propagation. Light travels with great speed equal to the 3 into 10 power 8 meter per second, and according to Newton, light is traveling faster in denser medium than in rarer medium. When he has given these hypotheses, the fellow scientist has raised some questions. So the fellow scientist has asked him a question: we are having different colors in light, then why we are having different colors? Then he has convinced his fellow scientist by saying the answer: different colors of light is because of the different sizes of corpuscles. Why we are having different colors means that is because of different sizes of corpuscles, he told. So that means all the corpuscles are not of same size, they are differing in size according to Newton. So he has told that different colors of light is because of different sizes of corpuscles. Why we are having different colors? Different colors are because of different colors or because of different sizes of corpuscles. Different sizes of corpuscles. And it is a convincing way for the fellow scientists, and they have accepted it. Even they have asked a question, why light is traveling faster in denser medium than in rarer medium? For that he has given the answer very simply like this. Suppose this is a line which is separating the two optical media. Media is the plural form for medium. So this is one optical medium and this is another optical medium. Let us consider this is denser medium, optically denser medium, and this is optically rarer medium. That means let us consider light is traveling from air medium to water medium. Air medium to water medium. Let us suppose that light is traveling. When it is traveling from a rarer medium to the denser medium in the form of straight line, as light travels in the rectilinear path. Now these are the corpuscles, they are coming towards the denser medium. We know that a rarer medium will be having the less dense molecules when compared with the denser medium. In a denser medium, molecules are more in number compared with the rarer medium. Therefore, when this corpuscle is entering into the denser medium, most of the molecules present in denser medium are pulling that corpuscles towards them. Therefore, it is gaining the speed. This is the explanative answer given by Newton. So what is the reason behind his explanation why light travels faster in denser medium than rarer medium means? He told that denser medium is consisting of more number of atoms and molecules compared with the rarer medium. Therefore, when the corpuscles are entering into the denser medium, the more number of atoms and molecules present in this one will attack that more powerfully. Therefore, it is gaining the speed. This is the explanative answer given by Mr. Newton. Hence, it is also a convincing way at that time. Therefore, the fellow scientists believed that light is traveling faster in denser medium than in a rarer medium. Okay. So these are the hypotheses put forward by Newton, and it was named as Newton's corpuscular theory. But here there are some drawbacks or failures of this theory. At present we will be knowing the failures. At that time we are not knowing about what are the drawbacks in this theory, but later on they came to know the different drawbacks present in this theory. As we studied in the first year, we have studied about the first chapter, that is physical world. There we have studied that in the field of science, sometimes we have to develop a theory, sometimes we need to give a correction for the existing theory, or sometimes we have to discard the existing theory and we have to go for a new theory. All these things are possible in the field of science. So here in the beginning, Newton's corpuscular theory was put forward in order to understand the light and its phenomenon. But later on, when this theory is not successful in explaining some of the newly observed optical phenomenon, they made some corrections and they have discarded some of the existing points. So as Newton told that light is traveling faster in denser medium than in rarer medium, this is a point put forward by him. But experimentally it was noticed that light is traveling faster in the rarer medium compared with the denser medium. This is experimentally proven fact. And because of that experimental evidence, this point is neglected, or this is a failure of this Newton's corpuscular theory. What is the failure of Newton's corpuscular theory means? Newton told that light is traveling faster in denser medium than in rarer medium, but in reality light travels faster in rarer medium than in denser medium. This is the failure of this Newton's corpuscular theory. And he told that different sizes, different colors are because of different sizes of the corpuscles, but in reality different colors are because of the different frequencies, and each color is associated with a particular wavelength. So, color is not because of wavelength. We might be feeling that color is because of wavelength. The reason for color is not the wavelength, but every color is associated with a particular wavelength. So, the reason for color is the frequency. So, what is the basic important reason for the color? Color is due to frequency, but each color is associated with a particular wavelength. And now, coming to this theory, so Newton has explained the reflection phenomenon. That means when you are standing by the side of a mirror or in front of a mirror, when you are standing, we can see our beautiful images. Yes or no? That is because of which phenomenon? Means because of reflection phenomenon. But we stand before a or nearby a calm surface of water, and you look into the water, we can see our image as well as we can see the objects inside the water. So, here we are able to see our image, means that is because of reflection. At the same time, we are also seeing the objects inside the water, that is because of the refraction phenomenon. One is because of reflection and the other is because of refraction. In this case, when you are standing by the side of a calm surface of water, we are observing the two optical phenomenon almost at the same time. That means, we are having the partial reflection, partial refraction. When light is falling on the calm surface of water, we are having partial reflection because of what we are able to see our image, and we are seeing the object inside them, means because of the refraction phenomenon. This partial reflection, partial refraction cannot be explained by Newton's corpuscular theory. So, the failure of Newton's corpuscular theory is what? Newton's corpuscular theory cannot explain partial reflection, partial refraction. It cannot explain why light is traveling faster in a rarer medium than in denser medium. He told that light is traveling faster in denser medium, but in reality light travels faster in rarer medium. And different colors are because of the different frequencies, and each frequency of color is associated with a particular wavelength. These are the drawbacks of this Newton's corpuscular theory. And what is the success of this theory? Means this theory can successfully explain the optical phenomenon like reflection and refraction. Reflection can be explained based on this. Even refraction can also be explained using the Newton's corpuscular theory. But it cannot explain the further newly observed phenomenon, optical phenomenon like interference, polarization, diffraction. These theory cannot be explained based on the Newton's corpuscular theory. So, Newton's corpuscular theory is a particle based theory. According to Newton, light is exhibiting the particle nature. Is it clear? And light is having the rectilinear propagation, and light travels faster in denser medium than in rarer medium, and different colors are because of the different sizes of the corpuscles. And what are the failures of this theory? It cannot explain the partial reflection and partial refraction when you stand by the side of a calm surface of water, or simply we can say that Newton's corpuscular theory failed to explain the partial reflection and partial refraction. It can explain the reflection and refraction phenomenon, but it cannot explain the newly observed optical phenomenon at that time called interference, diffraction and polarization. Is it clear? This is about the Newton's corpuscular theory. Next is about the Huygens wave theory. Christiaan Huygens is the one who has introduced this Huygens wave theory. The hypothesis of Christiaan's Huygens wave theory will be like this. Even though Huygens is a contemporary of Newton, that means who lived almost at the same time of Newton, his theory was not accepted. Though it was proposed almost some 10 years difference of the two theories, the Huygens wave theory was not accepted. Even though it is a successful theory compared with the Newton's corpuscular theory, his theory, Huygens theory was discarded for about 100 years because of the superiority of Newton in those days, or because of his success stories compared with the other scientists. Newton's corpuscular theory was blindly followed for about 100 years. Later on, Huygens wave theory was given importance. When does this Huygens wave theory was given importance? Means whenever they observed a phenomenon called interference, and that interference phenomenon cannot be explained based on the particle nature, the scientists tried to explain the observed interference pattern using the Huygens wave theory, and they were succeeded. So, the success of that interference phenomenon says that light is having the wave nature. Newton told that light is a particle, but Huygens told that light is a wave. So, when you treat light as a particle, we are unable to explain the phenomena like interference, diffraction, polarization. These are the phenomena which cannot be explained based on the Newton's corpuscular theory or the particle theory. But these theories were explained based on the wave concept. That's why the Huygens wave theory was given importance. But it has taken 100 years for this theory to be accepted, even though this theory was proposed almost at the same time of Newton's corpuscular theory. Okay, then what is the hypothesis of this Christiaan Huygens wave theory? So, Christiaan Huygens wave theory is proposed by whom? Huygens wave theory was proposed by Christiaan Huygens. And what does this theory says? According to this theory, light is having the wave nature. Christiaan Huygens wave theory. Christiaan Huygens wave theory. This theory says that light is having the wave nature. Light exhibits wave nature. And according to this theory, light travels faster in which medium? According to this theory, light travels faster in rarer medium than in denser medium. Light travels faster in rarer medium than in denser medium. Even experimentally also, the scientist has proved that light is going to travel faster in rarer medium than in denser medium. But according to Newton, it is traveling faster in denser medium. So, practically also we have understood that light is traveling faster in rarer medium, and Huygens wave theory also says that theoretically it says that light is traveling faster in rarer medium. So, theory is matching with the experimental results. Therefore, the Huygens wave theory was given importance after 100 years later of Newton's corpuscular theory. And next is different colors is because of what? Different frequencies, but each color is associated with a particular wavelength. Different colors will have different wavelengths. The reason for color is not the wavelength, but different colors are having different wavelengths. Different colors are having different wavelengths. Different colors are because of what? Different wavelengths. So, how to understand different colors are having the are because of the frequency or not because of the wavelength means I will tell you a simple example. Suppose a red color light is instant. You are having a laser beam with red color, and that laser light is made to instant on water or glass. When it is passing through the glass or water, what is the color that you are going to notice? The color that you are going to notice is red only. When a red color light is used, when it is passing through glass or when it is passing through water, it is having the red appearance only. The color won't change. So, when a wave is propagating from one medium to another medium, or when a wave is traveling from one optical medium to another optical medium, what is happening? So, we will be observing some changes in the parameters. What parameters are going to change when a wave is propagating from one optical medium to another optical medium? In first year also we have studied this. When a wave travels from one medium to another medium, its velocity is going to be affected because of the changes in elastic character of the medium and inertia character of the medium. The speed of a wave will depend upon the elastic character and inertia property. So, which we have studied in the first year. So, the speed is going to be affected and even the wavelength is going to be affected. But what does not change means the frequency does not change. Here I told that when light is passing, when a red light is passing through from air to glass, it appears red only. The color not altered. That means what is not altered when when a wave is propagating from one medium to another medium? Frequency does not alter. That means The color is because of frequency, but different colors are associated with different wavelengths. Have you understood it clearly? So, please don't think that color is the origin for color is wavelength is wrong, but every color will have the particular wavelength. Okay, different colors are having the different wavelengths. And now this is about the Christiaan's Huygens wave theory, and using this Christiaan Huygens wave theory, they succeeded in explaining the interference phenomenon. But here one more important thing that we have to remember regarding the Huygens wave theory is, at the time of proposal of this Huygens wave theory, they are more aware about the mechanical waves, but they are not aware about the non-mechanical waves. So, as in the previous electromagnetic wave theory topic, I have told you this. At that time of that, or at the before the 19th century, they are not aware about the non-mechanical wave concept. We are knowing about the non-mechanical wave concept only in the beginning of 19th century. But this theory was proposed in the 17th centuries in between 1700s and 1800s. This theory was proposed. At that time, they are not aware about the non-mechanical waves. That means they thought that there must be a medium for the propagation of any wave, because they are aware about the sound waves which require a material medium for their propagation. Not only sound waves, whatever may be the wave, a wave produced in a string or any kind of wave, earthquake waves or seismic waves, all these waves, they are requiring material medium for their propagation. So, in that aspect, Huygens did a mistake. Huygens also thought that this light is also requiring a medium for its propagation. Therefore, he proposed a medium called ether, which is pervading the whole universe. Therefore, Huygens thought that light is a mechanical wave. And he also told that light is a longitudinal mechanical wave. So, this is the important mistake that was done by Mr. Huygens. So, what he proposed means light is a longitudinal mechanical wave according to Huygens, not according to the actual concept, but according to Huygens, light is a longitudinal mechanical wave. As it is a mechanical wave, it requires a medium. Then what is a medium that is pervading the entire universe, that is occupying the entire universe? So, for that he has put forward some hypothetical medium called ether. So, according to Huygens, there is a medium called ether which is pervading the whole universe. According to Huygens, there is a medium called ether. It's very important point. Ether, which is pervading the whole universe, pervading the whole universe or the entire universe. In fact, there is no medium called ether. So, in the previous chapter, electromagnetic wave theory, I told, even the writer of the Sherlock Holmes story, the detective Sherlock Holmes story, Arthur Conan Doyle, he told that there is a Poisson belt in the universe. So, they have given importance for that theory called the theory which was proposed by Huygens. He told that there is a medium called ether. So, what he told? Huygens told that light is a longitudinal mechanical wave. As it is mechanical, it should require some medium. Then he has suggested a medium called ether for the fellow scientists, and he named that medium as ether medium. So, what are the drawbacks of this Christiaan Huygens wave theory now? So, what are the drawbacks means? He told that it is mechanical wave, but we came to know that from Maxwell's electromagnetic theory, we came to know that light is a non-mechanical medium. That means even light can travel through vacuum. Light does not require material medium for its propagation. If medium is present, no problem. If medium is not present, also no problem, because light can travel even through vacuum. Even experimentally also they have shown that light can propagate through vacuum. Therefore, light is not a mechanical wave, but it is a non-mechanical wave. Second thing is, he has told that light is a longitudinal wave. If you treat light as a longitudinal wave, we cannot explain the polarization phenomenon which was exhibited by the light. At that time, polarization is not known for that scientist, but later on the polarization concept is understood, or they have noticed the polarization phenomenon, and if they tried to explain the polarization phenomenon using the Huygens wave theory, they failed. Why? Because according to Huygens, light is a longitudinal wave, but if it is a longitudinal, it cannot be polarized. So therefore, light is but light is exhibiting the polarization phenomenon. That means light must not be longitudinal. Therefore, light is a transverse wave. So final conclusion of this Huygens wave theory, what are the drawbacks of this Huygens wave theory means, Huygens thought that light is a longitudinal wave, but light is a transverse wave. Huygens thought that light is a mechanical wave, but light is a non-mechanical wave. And he proposed a medium called ether, but in reality there is no medium called ether, because light can travel even through vacuum. How we came to know that there is no medium called ether means, two scientists named as Michelson and Morley, they conducted the experiment in order to calculate the speed of light. While they have conducted that experiment to calculate the speed of light, they thought that there is a medium called ether. While thinking that there is a medium called ether, they have expected some result, but they got the unexpected results. That means there is a flaw in that theory, and what is that flaw is, there should not be any medium called ether. Okay. This is how, though the Michelson-Morley experiment is a failure experiment, and that is a success for the modern physics. So from that theory, from that experiment only, we came to know that light can travel even through vacuum. Therefore, so though Michelson-Morley experiment is a failure experiment, but that is the beginning for the modern science or the quantum kind of physics. And now, so what are the important points regarding the Huygens wave theory means, light exhibits the wave nature, and light can travel with a great speed equal to speed of light, that is 3 into 10 power 8 meter per second. Light travels faster in rarer medium than in denser medium, and different colors are having the different wavelengths, and light is a longitudinal mechanical wave. According to Huygens, there is a medium called ether which is pervading the whole universe, and using this theory we are successful in explaining the reflection phenomenon, refraction phenomenon, interference and diffraction. But this theory failed to explain the polarization phenomenon, because he thought light is longitudinal, but light is a transverse wave. Okay. So this is about the Christiaan's Huygens wave theory. What are the failures of this theory? The failures of this theory is, Huygens proposed that it is a longitudinal mechanical wave, but light is a transverse non-mechanical wave. And the second thing is, this cannot explain the polarization phenomenon, and it cannot explain, Huygens wave theory cannot explain the newly observed phenomenon called photoelectric effect. So it can explain reflection, refraction, interference, diffraction, but cannot explain polarization and photoelectric effect and Compton effect. Photoelectric effect and Compton effect cannot be explained. Compton effect cannot be explained using this Huygens wave phenomenon. So now in the beginning of the story, we thought that light is behaving like a particle, but later on by the interval we came to know that light is behaving like a wave. But now when newly observed phenomena are noticed, like the photoelectric effect and Compton effect, what happened we will see here. Now is it clear? Next is about the Maxwell's electromagnetic theory. This is the third theory regarding the light. So what this theory says means, this theory was proposed by Clerk Maxwell. Who proposed this theory? Clerk Maxwell is the one who has proposed this electromagnetic theory. Proposed electromagnetic theory. According to this theory, light is a, which kind of wave means, light is a non-mechanical wave, and that too it is a transverse wave. According to Huygens, light is a longitudinal mechanical wave, but according to Maxwell, light is transverse non-mechanical wave. Transverse non-mechanical wave. That means it does not require any material medium for its propagation. So, in the previous chapter electromagnetic wave theory, I have told you about the Maxwell's concept, and according to this theory, light is having both electrical nature as well as the magnetic nature. So, light is an electromagnetic wave, means it is consisting of the electrical component as well as the magnetic component. And in this electromagnetic wave, if light is behaving like an electromagnetic wave, the electrical vector and magnetic vector are moving perpendicular to each other and also perpendicular to the direction of propagation of the wave. And the representation of electromagnetic wave I have shown you in the previous chapter, that is the electromagnetic wave theory. Suppose the wave is traveling along the z axis, this is x axis and this is y axis, which are mutually perpendicular to each other. If this represents the electrical wave, if this represents the electrical wave, then magnetic wave will be represented like this. And one more thing here we have to understand, means here this is the electrical wave which is sinusoidal, and this is the magnetic wave which is also sinusoidal. If you observe the two waves, they are in phase or they are out of phase. In the previous class I told you they are in phase, the electrical wave and the magnetic wave. This is magnetic wave which is along the YZ plane, and this is the electrical wave along the XZ plane. So, the oscillations of this electrical wave will be along x axis, the oscillations of magnetic wave is along the y axis, and this is the wave is propagating along the z axis. It is an electromagnetic wave. It will have the electrical component as well as the magnetic component, and this electromagnetic wave will be carrying the energy and momentum along with it. When it is carrying the energy and momentum along with it, it is going to apply some pressure on the surfaces on which they are falling, which is called as radiation pressure. And in an electromagnetic wave, the electrical wave can be represented like this: Ex is equal to E naught into sine kz minus omega t. Y minus sign means wave is propagating along positive z direction. In the similar way, magnetic wave is represented by By is equal to B naught into sine kz minus omega t. Here electrical wave, magnetic wave are perpendicular to each other and also perpendicular to the direction of propagation of the wave. Electrical wave and magnetic wave they are in phase, and these electromagnetic waves can travel even in the space, that means even in vacuum. So, this propagation does not require any material medium for its propagation, hence it is said to be the non-mechanical wave. And the speed of this electromagnetic wave is noticed to be, the speed of electromagnetic wave is given mathematically by the formula C is equal to square root of mu naught epsilon naught. This is the formula to calculate the speed of light as theoretically obtained by Maxwell, and it is coinciding with the practical results. And the value of this 1 by square root of mu naught epsilon naught, if you notice, you will be getting an answer which is equal to 2.99792,458 into 10 to the power of 8 meter per second, which is approximately equal to 3 into 10 to the power of 8 meter per second. So, the theoretical value of theoretically calculated value of speed of electromagnetic wave is matching with the experimentally calculated value of speed of light 3 into 10 power 8 meter per second. According to Maxwell's electromagnetic wave theory, the speed of light is given by the formula C is equal to 1 by square root of mu naught epsilon naught. Suppose the electromagnetic wave travels through any other medium, then the speed of light in that medium is given by the formula V is equal to 1 by square root of mu into epsilon. And using this electromagnetic wave theory, we are able to find out the refractive index of the given optical medium. And the refractive index of the given optical medium is given by n is equal to V by C, or according to these two, I can say that n is equal to square root of mu by mu naught into epsilon by epsilon naught, or else I can say that refractive index of the medium is equal to square root of mu r into epsilon r. This is the formula to calculate the optical density or refractive index. The other name for refractive index The other name for refractive index is optical density. I will discuss it afterwards. What is meant by optical density? Just like the density term, we will be having about the optical density in the optics chapter. So, optical density is also called as refractive index. Using this electromagnetic wave theory, we are able to calculate the optical density theoretically, knowing the electrical nature and magnetic nature of that optical medium. So, these are the success of this Maxwell's electromagnetic theory. What is the success of this Maxwell's electromagnetic theory means? Maxwell has put forward that light is a non-mechanical transverse wave. As it is a non-mechanical wave, it can travel even through vacuum, and experimentally we noticed that the light can travel even through vacuum. So, from sun to the earth, light is coming from traveling a lot of distance through vacuum only before entering into the earth atmosphere. So, the Maxwell theory also told that the speed of light is given by the formula 1 by square root of mu naught epsilon naught. That formula derivation is not there in our syllabus, but using the Maxwell's electrodynamic equations, we can get that formula, and using that formula, if you calculate the speed of light, the answer is matching with the experimentally noticed value. And not only that, if you want to calculate the speed of light in any other medium, then the speed of light in any other medium is given by the formula V is equal to 1 by square root of mu epsilon. And using this Maxwell's electromagnetic theory, one more important thing that we are able to find out is, we are able to find out the refractive index of a particular medium. Suppose two optical mediums are given, and we are asked the question which is optically denser and which is optically rarer. Then using this formula, we can find out which is an optically denser medium and which is an optically rarer medium. So, without using this V by C formula, we can find out the values. So, using this, we are able to find out the refractive index of that optical medium. And according to Maxwell, how light is traveling means it is traveling in the form of an electromagnetic wave. And Maxwell is a scientist who has unified electricity, magnetism and optics. So, all the three are put as a single subject, or he has unified all the three subjects as electromagnetic wave theory. And in this electromagnetic wave, electrical wave and magnetic wave are in phase. Though they are perpendicular to each other, but they are in phase. That means, by the time electrical wave is having maximum amplitude, magnetic wave is also having the maximum amplitude. The electrical and magnetic wave are mutually perpendicular to each other and also perpendicular to the direction of propagation of the wave. This is the representation for electromagnetic wave. And what is the drawback of this theory? And what is the success of this theory? Using this theory, we are able to explain all these reflection, refraction, interference, diffraction. Even we are able to explain the polarization. Previously, we are unable to explain the polarization, but using Maxwell's wave theory, we are successful in explaining the polarization phenomenon also. But this theory is not successful in explaining the photoelectric effect and Compton effect. Why? Because when we are going to use the wave nature of light in order to explain the photoelectric effect and Compton effect, we are failing. So, these two cannot be explained based on the wave nature of light. Now, in the beginning I told you that light is having the particle character. Later, we came to know that light is having the wave nature. But now again we had a doubt, because using wave nature we are able to explain up to here, but we are unable to explain these things, the newly observed optical phenomenon. Now we had a question. So, in order to explain the photoelectric effect and Compton effect, one more theory was proposed, that is called Max Planck quantum theory, which is the last theory that we are going to study in today's class. So, what is that theory? I will tell you now. So, what is the last theory? So, what is the demerits of this Maxwell's electromagnetic theory? The demerits is this theory cannot be useful in explaining the modern optical phenomenon like photoelectric effect and Compton effect. Okay. Next is about the Max Planck quantum theory. And who has proposed this Max Planck quantum theory means Max Planck is the one who has explained about this quantum theory of light. Actually, quantum theory of light is the one which was proposed in order to explain the black body radiation. For what purpose the quantum theory of light is proposed by Max Planck means in order to explain what the black body radiation concept. So, previously it was thought that the black body radiations are continuous. So, what is the nature of black body radiation? They are continuous, they thought. But later on we came to know that The black body cannot emit the radiation continuously, but it will emit the radiation discretely or discontinuously. So, finally, the black body radiations are continuous or discontinuous? They are discontinuous or discrete. Discrete in the sense discontinuous. So, for what purpose Max Planck has introduced this quantum theory? Means Max Planck has introduced the quantum theory in order to explain the black body radiations. Okay. This theory was put forward by Max Planck. This theory was put forwarded by Max Planck to explain what? To explain black body radiations. Black body radiations. Previously it was believed that the black body radiations are continuous. But after this Max Planck quantum theory, we came to know that the black body radiations are not continuous, but they are discrete or discontinuous. And according to this Max Planck quantum theory, light is emitted from a black body in the form of small packets of energy called quantum. Light is emitted in small packets called quantum. The plural form for this quantum is quanta. Quanta is the plural form for quantum. Quanta means plural form for quantum. Okay. So, according to Max Planck, light is emitted in small packets called what? Quantum. The energy associated with the quantum is given by energy associated with quantum is given by E is equal to n into h nu. Here nu stands for frequency, h stands for Planck's constant, and n is an integer number, where n is equal to 1, 2, 3, so on. So, that means energy of a quantum is nothing but integer multiple times h nu. That means h nu is the basic one, and any energy is there means that energy can be expressed in terms of this small value of h nu, in terms of integral multiples of this small value of h nu. That means if you are having an energy of a quantum, that energy might be either h nu or 2h nu or 3h nu or 1000 h nu. We never have half h nu, 3 by 2 h nu. That means fractional form of h nu is not available. So, we will be having only an integral format. So, that means integral format is there means I can say that it is quantized. In electrostatics, we have studied about the quantization of charge. What does the quantization of charge says? Quantization of charge we studied in electrostatics. The charge on any body or a particle is given by plus or minus, q is equal to plus or minus Ne, where n is an integer number, E is equal to charge of the magnitude of electron, which is 1.6 into 10 power minus 19 coulomb. That means charge of electron is a basic or the elementary charge. If there is any other charge, that charge must be expressed in terms of integral multiples of charge of electron. Why? Because the concept of charge is only arises because of excess of electrons or because of deficiency of electrons. So, excess of electrons means either one electron might be in excess or 10 electrons might be in excess. We cannot have half electron excess or 3 by 2 electrons excess. Because if there are students in this classroom, I have to say that either there may be some 50 students or 25 students or 3 students or 5 students, but I cannot say 3.5 students are present in the classroom. So, the number of students in the classroom is always an integer number, it never be fractional value. In the similar way, if the charge of, when you are trying to find out the charge on a body, the charge is raised either because of the excess of electrons or because of deficiency of electron. The number of excess electrons or the number of deficient electrons will be an integer number. We never have that 2.5 electrons are deficient or 2.5 electrons are excess. So, either 2 electrons might be excess or 3 electrons might be excess, yes or no. So, because in that way, that means charge on any body is always an integral multiple of charge of electron, which is the basic charge. In the similar way, if there is an energy associated with some packet, that energy of that packet must be integral multiples of h nu. Is it clear? So, this is from this one I can say that energy is quantized according to Max Planck quantum theory, or else I can say that energy is discrete. Something is quantized means I can say that that is discrete or discontinuous, because between h nu and 2h nu we are having a number of things, that is those are missing things. So, in according to quantum theory I can say that the packets of energy will be quantized. Okay. So, what I can understand from Max Planck quantum theory means this theory was put forward in order to explain what? Black body radiation. And from that we can say that he has proposed in order to explain that black body radiation, he has proposed that light consists of, or light is emitted in small packets called quantum, and the energy associated with the quantum is given by E is equal to integral multiples of h nu, where n is an integer number. That means energy is quantized, I can say. And using this Max Planck quantum theory, Einstein has succeeded in explaining the photoelectric effect. The photoelectric effect was explained by whom? Photoelectric effect was explained by Einstein, using whose ideas or using whose which theory he was explained the photoelectric effect means using the Max Planck quantum theory. So, photoelectric effect is an optical phenomenon which was explained successfully by whom? Einstein. Photoelectric effect is explained successfully by Einstein. But who discovered this photoelectric effect? Photoelectric effect is discovered by Hall, Watches and Hertz. Photoelectric effect is discovered by Hall, Watches and Hertz. Hall, Watches and Hertz. Heinrich Hertz. Discovered by Hertz and explained by Einstein. And this photoelectric effect is explained using the ideas of which theory? Using the ideas of Max Planck quantum theory. Max Planck quantum theory. And this photoelectric effect is experimentally verified by E. A. Millikan, who is a son of R. A. Millikan. E. A. Millikan is the son of R. A. Millikan. So, who has explained the oil drop experiment. R. A. Millikan is the one who has explained the oil drop experiment, or he is the one who calculated the charge of an oil drop. So, what regarding the photoelectric effect, we are having some 4 important scientist names are there. So, we must be cautious. Photoelectric effect is discovered by whom? Hall, Watches and Hertz. And this was explained by whom? Einstein. Using whose ideas Einstein explained the photoelectric effect? Using Max Planck quantum theory. And this was experimentally verified by E. A. Millikan. Is that clear? So, E. A. Millikan experimentally verified it and discovered by Hall, Watches, explained theoretically by Einstein using the ideas of Max Planck. The surprising thing is Einstein got the Nobel Prize in the year 1935 for explaining the photoelectric effect. He was not received the Nobel Prize for his famous E is equal to mc square equation, which relates energy with mass. Energy mass equivalence. For explaining energy mass equivalence, he has not received the Nobel Prize. For his famous special theory of relativity also, he has not received the Nobel Prize. He has received the Nobel Prize for explaining the photoelectric effect, not by using his ideas, and it was not discovered by him. So, for that photoelectric effect explanation, Einstein received the Nobel Prize. Is it clear? And now coming to this, Einstein, while he is explained the photoelectric effect, he has named this packet of energy proposed by Max Planck as the photon. Who named the packet of energy as photon means Einstein. According to quantum theory, the energy associated with any packet is given by E is equal to NH nu. That packet of energy is named as photon by Einstein. Packet of energy called quantum is named as photon, by Einstein. And Einstein thought this photon is a particle, light particle. So using that particle behavior of light, or using that photon nature, he successfully explained the photoelectric effect, and later Compton has explained the Compton effect. Compton is the name of a scientist who has explained the Compton effect using the photon or the Max Planck quantum theory. So that means this photoelectric effect and Compton effect, these are the optical phenomenon which can be explained only based on the particle nature. And these are the phenomenon which can be explained only based on the wave nature. So in examination they will be asking, name any two phenomena that can be explained only based on wave nature. Means either these two or these two or these two you can write. Name any two optical phenomena that can be explained only based on the particle nature. Photoelectric effect and Compton effect. So name the phenomenon that can be explained both based on wave nature as particle nature, reflection and refraction. Is it clear? So in the beginning of the story we have studied that light is exhibiting the particle nature. Later we have studied that light is exhibiting the wave character, and at the last again we came to the conclusion that light is behaving like a particle. Then finally what kind of nature the light is having is the question. So the question is left to us only now. So in the beginning light is having the particle nature, then wave nature, and once again we treated light as a particle. So the final conclusion of this four theories of light says that light is having the dual character. Light is exhibiting dual character. The conclusion of these theories of light is exhibiting dual character. That means it is exhibiting both particle character and wave character. So both character, can they be exhibited at the same time? That means can you see the particle nature and wave nature simultaneously? Simultaneously means at the same time. So what is the answer for this question is, light cannot exhibit the particle nature and wave nature simultaneously. Most important point. Light cannot exhibit both particle and wave character, simultaneously. Means if light is behaving like a particle, at that time wave nature is absent. If it is behaving like a wave, particle nature is absent. If one character is highlighted, the other character is absent. It is just like the split personalities. That means in some movies we have seen. In Aptarakshaka movie we have seen the characters of Ganga and Chandramukhi. If Ganga is present, Chandramukhi is absent, or if Chandramukhi is present, Ganga is absent. So we cannot see both the characters at the same time. Only one character can be seen at a particular instant of time. So if a particle character is there, which character is absent? Wave character is absent. If wave character is there, particle character is absent. But light can have both the natures. In explaining some phenomena, we are treating light as a wave. In explaining some other optical phenomenon, we are treating light as a particle. So in some cases we are treating it as a particle, in some other cases we are treating it as a wave. Is it clear? And now finally the photoelectric effect is explained by whom? Einstein, using whose ideas? Max Planck quantum theory. According to quantum theory, energy associated with the photons is given by E is equal to NH nu, and the rest mass of photon is 0. According to Einstein, rest mass of photon is 0, and if a photon is moving, it is having some mass. The mass associated with the moving matter is given by the formula m is equal to m naught divided by square root of 1 minus v square by c square. According to special theory of relativity, the mass of moving matter is given by m is equal to m naught divided by square root of 1 minus v square by c square, where m naught is the rest mass of the particle. So, what is the rest mass of photon? Rest mass of photon will be 0. Okay, when photon is moving, then only it will be treated as it is having some mass as well as it is having some energy. Okay. So, this is about the 4 important theories of light. What is the final conclusion? Light is having which character? It is having the dual character. If it is having dual character, can it exhibit both particle nature and wave nature simultaneously? No. When wave character is there, particle character is absent. When particle character is there, wave character is absent. So, finally, we have come to the conclusion that light is having the dual character. This is the about the theories of light. Next, we will be going to study about the ray optics. Okay. Listen here, while explaining the theories of light, I have skipped off Huygens wave principle. I have skipped off, as well as the other thing that is about the Huygens, what are meant by secondary wavelets. Those things I have skipped off. Why? Because I will those things are not necessary now. Before explaining the wave optics, I will explain that what is meant by Huygens principle. Until then, please wait. So, what are the topics I have skipped off? What is meant by Huygens principle I have skipped off. While explaining the Huygens wave theory, I have not told you what is the Huygens principle. I will tell you what is Huygens principle later before going to explain about the wave optics. And according to Maxwell, a time varying electric kind of magnetic field is producing a time varying magnetic field and vice versa. A time variable electric field will produce a time varying magnetic field, and a time varying magnetic field is in turn producing a time varying electric field. That is the important conclusion of electromagnetic theory, which we discussed in the electromagnetic wave theory chapter. Now, I am going with the ray optics or the geometrical optics, where we are going to use the simple geometry. So, what geometry we are going to use means, mainly if you are knowing about how to apply Pythagoras theorem, how to find out sin theta, cos theta and tan theta, this ray optics is not that much difficult. It is very easy thing. Just we have to know about Pythagoras theorem, application of sin theta, cos theta and the tan theta. Then we will be comfortable in understanding about the ray optics. What this ray optics says? In this ray optics, we will be treating light is a propagating in the form of straight line. What is meant by a ray then, and what is a optical medium, and to how many ways the optical mediums will be classified? First, I will tell you about the classification of medium. If you consider a medium can be classified into 3 types based on whether light is propagating through it or not propagating through it. So, then what is the classification we are having? If there is a medium, that medium can be classified into 3 types as optical medium, non-optical medium or opaque medium, and the third one is translucent medium. So, this is a classification that was made based on whether light is propagating through them or not propagating through them. If light is propagating through a particular medium, then that medium is said to be optical medium. Example, light can propagate through glass, therefore glass is an optical medium. Light can propagate through water, so water is an optical medium. Light can propagate through prism, so prism is an optical medium. Light can pass through a lens, so lens is an optical medium. Our eye, light can pass through our eyeball, so our eyeball is an optical medium. So, any medium that can propagate light is said to be the optical medium. Example for optical medium is what? We can take lens, prism, water, air, glass, etc. These are the examples for optical media. The plural form for medium is what? Media. Next, what is an opaque medium? The medium which cannot propagate light through them are said to be opaque medium. This wall or this board cannot pass the light through it. Yes sir, through the wall light cannot pass, through a book light cannot pass, through the duster light cannot pass. So, the medium through which light cannot propagate is said to be a non-optical medium or opaque medium simply. Examples for opaque medium is wall, duster, or a brick or whatever it may be. So, we can treat them to be an opaque medium. Then what are these translucent medium? So, translucent means these are the medium through which light can propagate partially. For example, litmus paper. So, when you take an oil paper, through the oil paper light can travel partially, or some type of glasses. So, light can propagate partially. So, such kind of mediums are said to be translucent medium. Translucent mediums are the media through which light will propagate partially. So, that is a translucent medium. Now, coming to the propagation of light, how the light is propagating according to ray optics. According to ray optics, light travels in the form of straight lines. Why light is traveling in the form of straight line means, when to take light as a straight line or when to take light as a wave means, suppose when the size of the object is very large compared with the wavelength of the light wave, then according to electromagnetic wave theory, light is having wave nature, I told you. Then here I am telling light is taken as a ray. When to take this light as a ray means, when the wavelength is very less compared with the size of the objects that we are considering. For example, in this ray optics chapter, we will be dealing with the prisms, we are dealing with lenses, we are dealing with curved surfaces. The sizes of the lenses will be of the order of centimeters. The size of the prism is also of the order of centimeters. Those centimeter size is very large compared with the wavelength of the visible light, which is of the order of 10 power minus 7 meter, because the visible light ranges from 400 nanometers to 800 nanometer roughly. In your textbook NCERT, they have given it as 750 nanometer. 750 nanometer according to NCERT textbook. Now, this is the rough range for the visible spectrum. So, in this one, this 400 nanometers can also be written as 4 into 10 power 2 into nano in the sense 10 power minus 9 meter. So, that means 4 into 10 to the power of minus 7 meter. So, the wavelength of visible light is of the order of 10 power minus 7 meter, which is very small compared with the sizes of the lenses or the sizes of the prisms. Therefore, in such a cases, whenever the sizes of the lenses or prisms are very large compared with the wavelength of light, we can treat light as a ray. For example, if this is a wave, this is said to be the wavelength, yes or no? If this wavelength is very small, then it will be like this. So, can I show the wavelength here? They are very close to each other, the waves are very close to each other, and it looks like a ray. So, whenever we are treating light is propagating in the form of a ray, then for the propagation it should have some direction. Therefore, the arrow of this will indicate the direction of propagation of light ray. So, light ray is represented graphically by a straight line followed by an arrow. A line followed by an arrow is the representation of a ray. This is the line and it is followed by an arrow. The arrow gives the direction of ray. Is it clear? So, this is the representation of ray in optics. So, the arrow indicates what? The arrow will indicate the direction of propagation. So, whenever we are using rays in optics part, compulsorily it must be followed by direction. Without direction, if you draw a straight line, it is meaningless while we are studying the optics part. So, the arrow will play major role in understanding about this ray optics or the geometrical optics. A ray is one which is followed by a line followed by an arrow mark, where the arrow indicates the direction of propagation of light ray. Now, regarding the light rays, this is a ray, this is also a ray, this is also a ray, this is also a ray. How I can call this? This is nothing but a what? A group of light rays or a collection of light rays or a pile of light rays, a bunch of light rays. Yes or no? This can be treated as what? Bunch of light rays or a collection of light rays or a pile of light rays. The group or the bunch of light rays or a collection of light rays is said to be a beam. It is said to be a beam. What is a beam of light? Beam of light is nothing but a collection of light rays or a group of light rays. Now if you see, these are the group of light rays. What about this? This is also a collection of light rays or not? Yes, this is also a collection of light rays. Not only this, even this is also a collection of light rays. This is also a collection of light rays. But what is the difference between this and this? Here the light rays are almost parallel to each other. These are the light rays which are parallel to each other. So this is said to be a parallel beam. Here a group of light rays are there, therefore it is a beam. Here also group of light rays are there, therefore it is also a beam. Here also group of light rays are there, therefore it is also a beam of light. But here there is a difference between this beam and this beam. This is a beam of light rays in which the light rays are parallel to each other, hence the name parallel beam. So this is parallel beam. Okay. Parallel beam means if there is a group of light rays which are parallel to each other, then it is said to be a parallel beam. But here there is a group, this is a group of light rays where the light rays are diverging, hence the name diverging beam. So this is said to be diverging beam. Diverging beam. And here this is a group of light rays where they are converging towards a point, or they appear to converge to a point. If a group of light rays converges towards a point, then that is said to be the converging beam. Converging beam. So what I can say, a group of light rays is said to be a beam, and the beam of light rays is of three types, as parallel beam, diverging beam and converging beam. If the light rays are parallel to each other, then it is said to be a parallel beam. If the light rays are diverging, then it is said to be a diverging beam. If the light rays are converging, then it is said to be a converging beam. So these things are important to understand the ray optics in a more clear way. In this ray optics, first we are going to study about what? We are going to study about the reflection phenomenon, and in next classes we are going to study about the refraction phenomenon. So first we are going to learn about what? Reflection. Reflection. In this reflection, first we will study what is reflection, then we will study reflection at plane surface, and then reflection at curved surface or the spherical mirrors. So what is reflection then? In order to understand reflection mathematically or theoretically, first we have to study some important terms related with the optics part, like what is meant by an interface, what is an optical medium. Already we discussed what is meant by an optical medium. Next thing is we have to study about the interface and what is normal line, incident ray, reflector ray, all these things we have to study. Okay. So first, what is reflection? So we are seeing our images in the mirrors. That is because of what phenomenon means? Because of reflection phenomenon. When you are standing by the side of a calm surface of water, we can notice our image in that calm surface of water. That is also because of reflection phenomenon. Is it clear? So suppose because of this reflection phenomenon, we are having some applications also. Due to reflection, we are having some applications. So later we will study about the applications of reflection. So then what is a reflection is the question here. To understand the reflection, we have to understand first what is meant by an interface. An interface is nothing but, let us consider this is a plane. It is not a line, but it is a plane. It is a plane like this. If this is a plane surface, it is a plane like this. And above this plane, one kind of optical medium is there, and below this plane, another kind of optical medium is there. Let us consider this is air medium. Air is an optical medium because light can propagate through air. And let us consider below this plane there is a glass. So this is the glass medium. Glass medium. Above it is air medium, and below it is glass medium. And this is a plane which is separating the two optical media. Yes or no? The plane which separates the two optical media is said to be an interface. This is said to be what? Interface. This term comes frequently. So what is this interface means? Interface is nothing but a plane which separates the two optical media. a plane which separates the two optical media is said to be an interface. So, above this interface we are having one kind of optical medium, and below this interface we are having another kind of optical medium. So, this is air, which is rarer medium, and this is glass, which is denser medium. Now, if this glass is silvered, then it is acting like a mirror, and here it is a plain glass I have taken, which is coated with silver. So, it is a reflecting surface, I can say. Why it is a reflecting surface? Now, this is an interface you have understood first. Now, I will draw a line like this. How this line is? This is a line perpendicular to the interface, yes or no? The line perpendicular to the interface is said to be the normal line. The other name for normal is perpendicular. So, the line which is perpendicular to the interface is said to be the normal line. It is very simple. So, normal line is very important in understanding the definitions of angle of incidence, angle of reflection, angle of refraction. So, that is why this normal line you have to understand first. What is interface? A plane which separates the two optical media is said to be an interface, and a line which is perpendicular to the interface is said to be the normal line. Now, I will consider a light ray which is falling on the air glass interface like this. This is the light ray which is falling on the air glass interface. Let me name it as PQ. What is this PQ? PQ is a light ray which is incident on the interface. The light ray which is incident is said to be the incident light ray. So, PQ is the incident light ray. PQ is incident light ray. Incident light ray. What is an incident ray? The light ray which is incident on the interface of two optical media is said to be an incident light ray. Now, after incidenting on the reflecting surface, this is the reflecting surface. Reflecting surface, you will notice that the light ray is coming back into the same medium. It is coming back, or it is bouncing into the same medium. So, from which medium it is through which medium it is traveling and falling on the interface, into the same medium this light ray is coming. So, this is said to be the reflected ray. This is said to be reflected ray, and this is incident ray. Incident ray. This is PQ, this is QR. PQ is the incident ray, QR is the reflected ray. Now, if you see the diagram, what we are understanding in this diagram means, first thing is interface. What is interface? A plane which separates the two optical media is said to be an interface. A line which is perpendicular to the interface is said to be the normal line. The light ray which is incident on the interface is said to be the incident ray, and light ray which is reflected is said to be the reflected ray. Then what is reflection? Reflection is an optical phenomenon, yes or no? Reflection is an optical phenomenon here. An optical phenomenon in which a light ray bounces into the same medium, or comes back into the same medium is said to be the reflection. An optical phenomenon in which an incident light ray will bounce into the same medium, or an optical phenomenon in which the incident light ray comes back into the same medium after falling on the interface. After falling on the interface is said to be the reflection phenomenon. So, I am writing the definition for reflection. Reflection definition. Reflection. The optical phenomenon in which the optical phenomenon in which the incident light ray comes back into same medium after falling on the interface, the interface, after falling on the interface is called reflection. So, because of reflection what we can see? We can see our images in the mirror because of what? Reflection. And based on reflection we are having the spherical mirrors we are using in car mirrors or in so many mirrors we will be using. The reflecting type of mirrors we are using to see the images of the objects. Okay. Now, this is the incident ray, this is the normal line. Between these two there is some angle. Yes sir. This angle is named as I, angle I. What is this angle I? It is called as angle of incidence. Angle I, it is called as angle of incidence. Angle of incidence. What is this angle of incidence? Angle of incidence, by seeing the diagram we can say angle of incidence is an angle between the incident ray and the normal line. The angle of incidence is the angle between the incident ray and the normal line. Then yourself you tell what is the angle of reflection means. So, angle of reflection is the angle between dash and dash. It is the angle between reflected ray and the normal line. So, the angle between the reflected ray and normal line is said to be the angle of reflection. Angle R stands for angle of reflection. Angle of reflection. Is that clear? So, the angle between incident ray and normal is called angle of incidence. The angle between reflected ray and normal line is said to be the angle of reflection. And here we have to study about the laws of reflection. What we have to study? The laws of reflection we have to study. After understanding the laws of reflection, we will go with the reflection at plane surfaces and reflection at the spherical mirrors or the curved mirrors. Is that clear? Okay.